Hi, it's Todd of Todd's Workshop and Todd Cutler here, and today we're back to talk about pattern welding. And that is where you get two dissimilar steels, forge weld them together, etch the result, and if you've manipulated them nicely, you end up with some pretty groovy patterns. This was made by my friend and very good pattern welder, Owen Bush. But earlier in the year, I did a film with Owen about a sword that he'd done for an author, JC Duncan, and his book A Song of Steel. And it was a complicated sword, sort of Viking inspired sword. But we talked through a lot about the pattern welding process. But as is ever the way, a lot of that ended up, because it wasn't really for that film, on the edit room floor. So we've brought it back because it is an interesting subject. Brought it back, put it together here. And so really this is the outtake of Owen demonstrating and showing how to pattern weld, how you do it with plasticine to work your way through the patterns, and what the process is all about. So I hope you enjoy it. But here you go. Todd and Owen chatting about pattern welding, him demonstrating, me standing by in wonder, really. Thanks. I hope you enjoy.
I'll have a chat about the pattern welding because I'd like to try and explain some of the pattern welding that's gone into this.
Yeah, I mean, that's interesting because, you know, how you manipulate plasticine, I think is a fantastic thing because you just sit there working patterns out, don't you, by weaving, folding, cutting plasticine.
Some of it in steel and then some of it in plasticine.
And that gives you your groundwork before you commit to the steel.
So we look at one of the simplest patterns. So I've got two coloured plasticines here. In a Viking or Saxon sword, that would represent probably phosphoric iron and wrought iron, the materials that would be used in the core. Phosphoric iron reacts to acids in a different way and is a slightly stiffer material than wrought iron. And obviously they'd have edges that are made of steel encapsulated in wrought iron, very similar to the way that a Japanese sword is made, but more complicated. So I'm going to make up a nine layer bar. Just a simple...
And this is effectively how you would do it in the forge, but with metal?
Yes, absolutely. I'm taking different steels and iron with different qualities and putting them together and then forge welding them. And I'm forge welding them just by squashing. And this is plasticine that I did heat up, but it's cooled down now. And it joins in a very similar way to the way that the metal does. We're using pressure and contact.
So, you know, in a modern context, we think of welding, you know, getting your electric welder out. But of course, they were welding in forges. So
yeah, so it's a solid state fusion. It's hammer welding, forge welding, fire welding, lots of different words for the same thing. And it's a way of joining material pre-modern electric welding. So I've forge welded these together now. Put a bit of heat in there with my hands, and I'm just going to twist the bar. So if I just twist it. Like I say, originally this twisting may have been, I believe it would have been there as a proof of the material quality, to show that the material is good enough to have been twisted. But it also produces quite beautiful patterns. Now the patterns change as you look through the material. So we look at a bar now, I've got diagonal lines going through it. It's not particularly interesting.
It's also quite messy.
Yeah. If I was to cut into this, though, you'll start to see what's going on inside. And what's going on inside is very complicated. So on the surface, we just have a diagonal striping. As I cut through it, we'll start cutting into those overlapped helixes. And it changes quite dramatically.
Yeah, fantastic.
So you start getting crosses. If I take another cut, you can see how it changes as it goes to the middle. So this is a very simple pattern. It's just 9 layers, but you get some quite wonderful and complex.
Yeah. So you've just cut it in a different place, and you end up like here with a completely different pattern set.
Yeah. And you can see that over there. And if you're looking at old swords, obviously part of the job of the swordsmith is to try and reinterpret what you're seeing on the face of the blade to make it and reproduce it yourself. And this is a traditional, quite simple, low layer sword core. I say simple, I'm saying that now with 25 years of experience behind it.
Well, it looks simple in plasticine.
Yes, absolutely. And for me, it would be a relatively simple thing to do in steel as well.
Well, you know, clearly you've proved that you can do it in plasticine, but that's a very different thing to doing it in steel. So show me how you do it.
Yeah, I will. It's remarkably similar. I'm starting with a 15-layer billet, and this is alternating layers of bright and dark steel. That gets put into the fire, and then I'm going to forge weld it all together. Now I'm taking the billet out of the fire, it's going under a press to be squashed so that everything inside the billet is touching. Then I'll put it back in the fire. And now the billet has borax on it, and that's a flux that protects the outside of the material from oxidization. And you'll see that being sprayed off when we hammer it. And it's going under the power hammer. And the power hammer is similar to the press in that it squashes the layers of material together and forges them into one block. And now I'm forging the block of steel down into a section that I can twist. So I'm hammering it and hammering it on the power hammer until it's the right size for me to be able to take, put in a vise and then twist. I'm twisting this steel. Every half turn that I twist will give me one repetition of pattern, one cross in the final pattern. Now I'm twisting the steel again just because I want to get a bit more pattern into this piece. I stop twisting as soon as the material ends up getting too cold or I think that I've done enough of the twisting. Now I'm grinding the steel. The pattern we have on the outside of the bar is not that interesting, it's just diagonal lines. So I'm grinding into the bar where some of those complicated helix overlapping shapes occur so that we can get a pretty final pattern on the bar. I'm etching the bar into ferric chloride, which is an acid salt, and it's not creating the pattern. Etching the steel just shows you the different layers of steel against one another. One of the steels in here is bright, and two of the steels in here are dark, and so what we're seeing in the pattern are these different layers as they react with the ferric chloride, as they oxidize. So when I'm making a blade, I use a power hammer and a press, but the process is identical to the one that would have been used by Viking smiths making sword like these. They would have been using hand hammers and possibly had a team of people using sledgehammers. But the process is pretty much identical. I just have a large machine to do it instead of a guy with a sledgehammer.